Good morning, students. Today we have discussing inverter. In this presentation we have discussing introduction of inverter, application of inverter, classification of inverter, operation of single phase full bridge inverter, waveform and analysis of full bridge inverter. Because we have discussing small due to some basics are in our chapter, not in a detail. Introduction. Inverter. Inverter is a device which converts DC supply into AC supply. Okay, voltage with desired magnitude and frequency at the output side. It is also known as DC to AC converter. Ideal and practical inverter has sinusoidal and non-sinusoidal waveform at output respectively. If the input DC is a voltage source, the inverter is called a voltage source inverter, means VSI. One can similarly think to a current source inverter CSI, where the input to the circuit is a current source. The VSI circuit has direct control over output AC voltage versus the CSI control output AC current. Application of inverter. For low and medium power application, square wave, cosine square wave voltage may be acceptable. For high power application, low distorted sinusoidal waveform are required. Using high speed power semiconductor device, the harmonic contents at output can be reduced by pulse width modulation techniques. Industrial application, variable AC motor, induction heating, standby power supply, UPS, uninterrupted power supply. Inputs are battery, fuel cell, solar cell and other DC sources. Classification of inverter. Inverter may be classified into two types, single phase inverter and three phase inverter. Only basically single phase inverter in our syllabus. Turn on and turn off controlling devices are, because in a SCR we have used silicon control rectifier, we have also used as a switching device in a inverter circuit. Bipolar junction transistor BJT also use. MOSFET we have used as a switching device. IGBT also use. GTO gate turn off thyristor also use in operation of single phase full bridge inverter. It consists of 4 choppers. We have also used at the BJT, IGBT, MOSFET as the same place of chopper. Full bridge converter is also basic circuit to convert DC to AC, and AC output is synthesized from a DC input by closing and opening switches in an appropriate sequence. First we have using a terminal T1, second we have using a terminal T2. There are also 4 different states depending on the switch are closed and open. When transistor T1 and T2 are turned on simultaneously, the output voltage appear across the load. If the transistor and are turned on at the same time, the voltage across the reverse end is minus Vs. Transistor T1 and T2 act as a switch S1 and S2 respectively. You have seen in this. There we have used transistor T1, T2, T3 and T4. We have used a parallel diode for reverse blocking mode. We have supplied the DC voltage we have denoted in a slide is Vs, source voltage. There the switch S1, S2, S3 and S4. Only R load circuit are available in our syllabus. This is the single phase full bridge inverter and the equivalent circuit. when S1 and S2 turn off and S3 and S4 is turned on, then figure is this: S1 open circuit, S3 is closed and S4 is closed. Then the waveform is in negative. The output voltage occurs in a negative plane. Again, next slide. The output voltage, load voltage, alternate between plus voltage source and T1 and T2 are on, and minus Vs when the T3 and T4 are on, respective of the direction of current flow. It is assumed that the load current does not become discontinuous at any time. In the following analysis, we assume that the load current does not become discontinuous at any time, same as for the half bridge circuit. Bridge inverter as preferred over the other arrangement is high power ratings. With the same DC input voltage, output voltage is twice than the half bridge inverter. This is the basic waveform in a square condition. Switch Q1 and Q3 are open and Q2 and Q4 are open. Okay, and some basic analysis of full bridge. The fundamental RMS output voltage V01 RMS means 4 Vs upon pi by root 2. The value is 0.90 Vs. Then RMS output voltage is Vrms equal to Vs. Thank you.